Yes.
Great. Let me just quickly go through this then without wasting much of the time. Hey guys, we are here to talk about a sort of opportunity which we have done as part of the ORAN. OCloud, as we know, is the cloud layer, the infra layer, which is actually providing the complete infrastructure for the cloud for the RAN specific elements to be deployed. And as part of the SMO work over there, what I have seen is why don't we take the help of the latest technology in trends? That's something which is happening on CNCF. And how can we use that specific piece of the code or the implementation of functionality across multiple communities? I'm talking of different open source communities, especially involved in LFN. I'll keep this specific topic, when I say cross community, I'm talking about mostly the LFN scope. And LF scope, to be more precise. LFN is where I can say all the orchestration layers happening in LFN is where we will be talking about. Having said that, the way we will move on is I want to give a brief introduction to how the operator itself works, because most of the guys I'm sure have been working on operators. If not, this session we will start with the introduction of how the KTS operator actually works. And what is the intention, what are the benefits of it, and then how that specific thing can be extended to a functionality of the OCloud. When I talk of OCloud actually has multiple functionalities. Out of this, we'll be mainly talking of the IMS part, that is FOCOM, coming from the orchestration layer. So we'll be mainly talking of the FOCOM part, which we have done as part of demonstration. And my friends from Sishi and Sunny will be talking about the demo part. Okay, that's how we have decided it. And feel free to stop me, interrupt me, and then ask questions if you have any as we proceed on this. Thank you. Having said that, yeah, this is something which I've taken as an introduction directly from the horse's mouth from CNCF.io blogs. I've seen multiple things in the blog which was there is something which felt like that's a good introduction part, so I've borrowed it from there. Well, what it talks about is the operator. The operator concept was introduced back in 2016. It's not something very new. It has been there, close to 8 years right now. And what have been happening there is that we actually see that, KTS as such, Kubernetes, when I say Kubernetes actually provides you the kind of APIs which are required for you. But that APIs are not enough when you want to have a functionality end-to-end from application perspective. So what this KTS operator provides you is that support, that software extensions, and that extensions over the Kubernetes API to extend the behavior. By that, what we mean is, in a way, it provides you those handlers using which you can actually extend the functionality. And then operator is a controller. If you have worked on the CRDs and CCs of the Kubernetes world, then this actually is a controller layer that actually helps you to have the resource defined, and the defined resource can be then executed using the Kubernetes API. So in short, it actually, what it does is operator is a controller that extends the functionality of the API and manages complex instances of the application for the user. So with that, the user will get a handler using which he can then change, or he can then modify the state of the specific resource, which is actually running on the Kubernetes layer. Well, if it's too abstract, don't worry, we'll be going in details of it. I've actually tried to explain this much detailed level in the coming slides. So here it is. The other thing I wanted to talk was also on terms of Helm versus Kubernetes. When I presented this slide deck back in April in the ORAN, SE, and other places, I have also talked about this in other communities also. I had this question about how is Kubernetes different from Helm charts, right? Because people have been habituated to Helm, and there was a question about can we do the same with Helm? I want to just clarify this part of it before we actually get into what Kubernetes operator is all about. So Helm is a package manager for Kubernetes. It is something which will help you to have your content or have your metadata as well as the data required for your operator for your resource to work in a specific order. Okay, and that's actually a sort of analogy which actually gives you the way you can define your packages, your files which are required for you to do the operation, and also how the files should be looked into. And they are called Helm charts, which actually gives you a YAML-based thing, key value pair with a specific indentation for each of the resource to be defined. And then that is actually then packaged and then published on top of Kubernetes. Kubernetes will then read it and then publish it. Whereas operators represent the evolution of package that can even use Helm. For that case, operators can also be developed on top of Helm. And operators actually complement Helm chart because they are the ones who help you to write a definition, a CRD as we call it, the custom resource definition, and also the way the definition drives the controller. I mean, it gives instructions to the controller as to how this specific thing has to work. So I would say Kubernetes operator is the logic which can be implemented using Helm. And the complete business logic of a specific controller can be implemented in a Helm way and then packaged and then shipped to the Kubernetes. That way we will actually have the complete end-to-end development or end-to-end functionality implemented. Okay. Now, what are the benefits of using operators? Okay. Well, the benefits are boundless, I would say, at this point of it, but it's simplify the complex task because we have been talking about only the definition part in Kubernetes. But here, when it comes to operator, the main advantage you're going to have is you're going to have the automation of variety of tasks. By that, what we are talking about is like deploying, scaling, managing databases, monitoring, and logging, and much more to it. All these complex tasks can be, can be streamlined, can be actually have a specific functionality defined, and you actually can pass on the parameters, and you can define the workflows for that, or you can define the way it has to work with different dynamic parameters coming from the user. That way, what will happen is your workflows will be dynamic in nature, and you can actually do your operations in a seamless way. You can do it, you can write it once and then replicate it multiple times, depending on for different business use case also. So it increases reliability and efficiency because of that. As we said, we can actually do the elasticity with that. We can do replication of that. And also the standardization of operations will happen because of this operator usage. Of course, better resource utilization because you are using the operators on top of Kubernetes. So you know how many resources are required. You can manage those resources. I mean, you can scale in, scale out. You can actually do all those other operations on top of resources. So resource utilization will be much better. You'll have better control over resources because every resource is your own custom defined. And then you will actually have control on when the resource, what should be the life cycle of resource, should be a state of the resource. And that is what will give you a complete control over the resource and also the utilization of those resources. And that also helps you to actually have better upgrades and maintenance. Why? Because when you know that a specific resource has to be updated, you have to patch a specific resource, you can just go to that and then update it. We'll also see how it can be done. And there is also a public operator catalogs for those of you who want to take a look at it. I mean, operatorhub.io gives you all those operators which are there. These operators are ready-made for you. You can just take them, deploy them on need basis, and then they'll be plug and play. That gives you even the flexibility of reusability over the long period of time. Okay. Now, here we talk about how operators actually work. As we said, what we require to have a Kubernetes operator is first is a custom resource. The resource are those elements which will run on top of Kubernetes. Okay, when we talk about resource, we are talking about those operator custom defined resources, which are extensions to Kubernetes API. And what we do is actually we use a reconciliation part of the Kubernetes where we have a desired state versus the actual state. And the reconciliation continuously works to see, how much of the work is going on, what is the current change. And controller, which is actually running, the operator controller, as you see here, I hope you can see my mouse, is the one which will be continuously watching for the changes in the resource. Any change in that will be then put back onto the specific resource running on top of Kubernetes. And then we'll be actually getting the current state. So there is always a mapper between a reconciliation going on between current state and the desired state. And this is what will help the user to modify the resources dynamically. All the modifications come. That action which we talk about, the controller takes action based on the desired state of the custom resource. The change can even come from here. Sometimes what will happen is due to some external event, the current state can change. Then the advantage that you're going to have is the operator will know that this current state is not as per what is desired, and then it can also reconcile it. It can bring back to the proper state of it. And the same can also come from user. So two events, both the events which are coming from the user as well as from system are being mapped into the desired state, and then we can actually have the complete operations done. So the controller reports back the Kubernetes API servers, as we talked about here, server to the control resource. So basically what we're talking about is the way we can bind this state to what is required. So there's always a mapper between whether my current state is as per the actual need. If not, we can actually change it. That is the reconciliation top which we are talking about. The operator continuously works on top of it. Operator's development, what we have to do a specific operator is we have to first of all identify the task to automate, then choose an operator framework. Then we have to define the custom resources of it, write a controller, test operator, deploy operator, monitor and maintain operator. So these are basically the steps which we require to have an operator development. For the current case of OCloud, which we have been talking about, we'll see how we have implemented all of this. Any questions so far, guys, before I jump into the actual topic? So far, I've been talking about the operator introduction, and I was quick on this because I'm sure most of you will know it. If any specific questions on it, I want to take it before I jump onto the actual topic of it. Hello? Am I audible, first of all, guys? I mean, can you hear me?
Hi, Sheshu.
Yes.
Yeah, Sheshu, this is Yogen.
Yeah, hi, Yogen.
Yeah, Sheshu, one question which I want to ask is, does this also enable any, like a brownfield customer, who wants to come to do a migration story for him, right? So typically they also have a management plane and a network element they will build it to do all of that, right? Is there a option to do that transition for them gracefully so that there's a little effort required, but the whole transition can be taken care?
Yogen, I will answer your question by the end of this slide deck. If not, you can get back to me because I will be exactly answering that as part of the cross-community collaboration part. Okay. If I don't answer it by then, maybe we can actually have this question again. Is it okay, Yogen?
Yeah, perfectly fine, Sheshu. Yeah,
sure. Yeah, thanks. And by the way, actually, you got the right question because that is the purpose of this entire operation. We are not talking of complete greenfield where we have to bring from scratch. The question which Yogen is actually asking you guys is that, this is all good, this technology is good, but what about the code which is already written? I mean, all the codes which I have already written and deployed there, right? What about that? Is it required for me to write it from scratch every time I want to go with operator, or I can actually implement such a way that the existing code can be reused again, right? That's your question, isn't it, Yogen?
Exactly. Yeah.
So the part of this, as I said, cross-community collaboration, I have actually addressed the same thing, Yogen. By the end of it, if it's not answered completely, then I'll be taking their question back. Okay, sure. Thank you. Then I want to give a brief introduction about Nefio. I mean, why I'm getting Nefio into picture is because Nefio is a open source project which we have been hearing about. There are a lot of topics even on top of Nefio also, which are there placed in the current DTF also in the coming days. And it is a pretty good project which is backed by Google, and it actually works operators. It works on top of operators, to be more precise. So if I have to talk about Nefio, what it actually does in a very crisp and short form of it, Nefio is the one which actually talks about these two layers. I mean, you can see the scope of Nefio, if I have to say. What we have is the infrastructure layer, okay, the infrastructure or orchestration layer, and then domain orchestration, which is specific for the resources on top of the infra, that is CNFs, I can say, right? So these two is what will be the scope of Nefio, and then we may even have an end-to-end service orchestration layer, which can bind this. So I'm part of the Nefio TSC2, and as part of this, when I saw the scope of Nefio, I can see that the concept which has been brought in here, right? I mean, about it's using the KRM, not Helm, by the way, right now, but maybe in future we'll also go Helm way. But the concept which is there here is pretty good for us to extend it even for other places also. So that is here. And if I have to go with other part of it, then this specific thing which we talk about is what we are building. I mean, we are building this KDS operator for the O2M, which is the IMS part. As I said, I'm also the PTL of SMO. And as part of that, what we have done is the FOCOM or the IMS, O2 IMS interface on the SMO side, orchestration side, is what is our primary target right now through this operation. So what we have here is 3 layers. As we said, we can broadly classify these 3 layers as cloud infra, the workload of resources, which is the network functions on top of it, and then the configuration, network configurations, which are required for these workflows to work properly. So these 3 layers are the one which we actually talk about from Nefio perspective. And as a starting step of this, what we have introduced this cloud infra, we have taken as a OCloud from the ORAN perspective, ORAN SE. And then we are building this specific KDS operator on top of it, which will be interacting with the KDS, will be interacting with this OCloud through IMS interfaces. Okay, that's our major goal in this. So then I want to actually talk about the ORAN architecture. sorry about this. Yeah. So what I was showing sometime before is the Nefio way of interacting with the cloud infra and all. If you come to ORAN part of it, the O2 interface, which you see here, I mean, the SMO service management function on orchestration framework is the SMO piece, which is interacting with OCloud using this O2 interface. O2, again, as I said, has two major positions. One is for the FOCOM, which takes care of the infra. That is the cloud and the, and if you're talking of distributed cloud of it, we are talking about the far edge clouds and the system control, centralized cloud. So that deployment of the clouds and the management of the clouds, LCM on the clouds is what will be taking care of the FOCOM. Then there's NFO piece also inside the O2, which will be talking about the payload or the workload on top of this. So if I have to talk to this particular thing, one is, of course, the cloud infra part, which is the FOCOM layer of it, which is managed by the SMO or FOCOM. And then the Kubernetes layer on top of it, which actually takes care of the load, that is actually coming from NFO, that is network function orchestration. So we have right now taken as a sample of it as a POC to this proof of concept, we have taken the FOCOM part, which is mainly talking about the way you can deploy the cloud infra and also manage those resources of cloud. Okay, that is the scope right now. And this is how it works. I mean, I've been talking about the operator as such. Now we will talk about how did we achieve the same using the operators for the OCloud operation. So as we said, OCloud operations provide infrastructure automation, allows user to provision subclouds across multiple edge locations. So when we're talking about subclouds, we are talking about each of those cloud. I mean, I'll show you that in this diagram if I have to illustrate it further. So basically what we have here is a distributed cloud, a central cloud, and each of these edges which we are talking about, each of them is a subcloud, okay? So this subcloud, I have taken this as Starling as an example, which is a pretty good distributed cloud, which is also being used in ORAN SE. So using that, what I wanted to illustrate is how this cloud will look like. So basically what a OCloud is constitutes actually is of all these elements which are there, where we can actually have a central cloud, which is like the controller layer, and then you can actually have subclouds beyond it. Each of these subclouds will work as an edge cloud. We have been talking about UPF in the previous slide too. Our friend was actually talking about how an edge cloud should look like. So all of them are the edge clouds which we are talking about. So these edge clouds can be managed through the O2 IMS interface, which actually goes from this, and the orchestration sits on top of it. So what we are trying to do in this is we are trying to define a custom resource, and that custom resource watches for changes of the custom controller. And then, I mean, this slide has to go a little here. Sorry for that overlap. And then take actions for managed projects. So what we are trying to do is we are trying to define a custom resource, and the custom resource will continuously watch for changes in the state or for the user input as well as coming from the external element. And then it'll then do the corresponding LCM operations on top of it to make sure that the state of the complete cloud as such, both central and subclouds are maintained. Okay, for this, what we have done is we have taken Ansible scripts which are interacting with this. And that's the question which Yogen was asking about, whether we have to rewrite something or we can actually have the existing code also implemented. It can be done both the ways. Like what we have done in this case is we have brought in the Ansible, but also you can reuse the code which is there for this. What you have to do is you have to just execute that particular thing as a package on top of the KRS operator, and then we can actually deploy it. I'll also talk about this as to what we are trying to do with open source code. So Yogen, you'll get more information about it once I go to the next part of it. So post demo, I'll be showing that how can this particular thing will be deployed into the scope of different operations or different current open source projects. So
hey, Sachin, do you mind if I ask a few just probably basic and perhaps slightly stupid questions?
Yep.
Just because they might be shared and also for myself. So really quickly, so the OCloud concept, is that sort of coming from like Nefio, from ORAN SE, from ONAP? Is this sort of, your kind of, way of describing, kind of the technologies amongst, sort of all of them? So apologies for something that's stupid and basic to ask, but.
Okay, no question stupid, Heather. I'm glad that you have asked this. So OCloud is the concept of the infrastructure layer, which has been named in the ORAN. Okay, ORAN, as we know, is a project in the LF, right? OCloud is the infrastructure layer. I was showing this particular thing here, right, where we are talking about cloud infra. This cloud infra can be anything. If you are talking about ORAN, ORAN is a specification body. I mean, if I have to say standardization body, which is mainly talking about RAN resources being deployed on cloud. Okay, this is generic mode of it, how it looks. If you are talking about a generic cloud infra with respect to Kubernetes and all, the CNF, how it should work, this is how it looks like. You will have a cloud infra, you will have Kubernetes on top of it, and then you will have CNFs, right?
Okay.
So the management of this can be anything. For example, here I can put ONAP or MCO, for example, right? I can also put other operations which are there. So if I have to talk from an LFN perspective, ONAP comes here. MCO is something which will come here. And then you will have the CNFs deployed on top of Kubernetes.
Okay.
And then the Kubernetes is running on cloud infra. Okay.
Okay. And OCloud is the ORAN sort of definition of the cloud infrastructure layer.
So this is, I can say this is one of those use cases which is talking with respect to RAN. Okay. In RAN specific thing, when you come to it, you see ODU, ORU, okay, the DURU, which we have talked about, and then CU, the radio unit, distributed and centralized unit, and then we are talking about all those deployed on top of the infra. The infra here is called OCloud.
Okay. All right. And then one final, so that actually clears up several questions I was about to ask you. So thank you for that. And thank you for drawing. Obviously, you thought about it and it was here in your diagrams, but it wasn't just connecting for me yet. So one other question here, which is sort of around collaboration with Anuket. And unfortunately, I think a lot of our Anuket folks dropped because we do have a parallel Anuket TSC meeting going on right now. But is there... so, you know, when we start talking infrastructure, and I think that you had it on a previous diagram, you know, do you think that there is adequate sort of communication and collaboration going on sort of between ORAN and Anuket, so that as Anuket is defining infrastructure, they understand sort of the requirements that are coming from ORAN, or, you know, kind of to go back to our sort of, you know, inter-community collaboration, you know, sort of topic. Is there something that needs to be improved there, do you think?
Right. So I am not part of Anuket. I'm part of multiple projects, but on Anuket. So you know it. I'm part of ONAP, NFO, Silva, ORAN, ORAN SC, everything, MCO, of course, XGVela, of course. So all those projects is what I have put. If I don't answer that question by end of my deck, I'll take this separately. Okay. I have one deck where I have actually tried to put all those elements which we talked about, in which I can also draw a line about, I have not yet put Anuket, but surely I can draw a line as to where Anuket can even come. Okay. And then we will see how these all projects which I've talked about can actually correlate this specific use case. Okay. Fair enough.
Yep. Nope. That makes sense. All right. So that answered my question. So feel free to go back to your regularly scheduled and in progress presentation.
Thank you.
Seshu, can I ask one question? I have several, but for now, so you're from OSC perspective, you focus on the FACOM traction toward the nephew connection to operator. That's the first priority, then NFO.
Yes, I'll be talking about it as part of next steps too. I'm happy to say that I have actually answered all your questions as part of my deck before. I'll come to that part too as part of my next steps, Byung. I'm glad you asked this. By the way, I've also shared this deck to ORAN SC, and I got there was a very good feedback which we got as part of the ORAN SC and also TOC, ORAN SC TOC also. So even our common friends, Kenny, John and other people are also there in that, who also have shown their interest in this. What we are trying to do right now is a POC just as a starting point to it, where we will do it for IMS. But the same can also be extended for NFO also, and even other places. Basically, OCloud is a complete infra layer, as I talked about. What we are trying to do is one part of the element, that is the FOCOM part or the infra or the IMS part. But the logic of it, what the concept which we are trying to use, the operator can be extended even for other places also. There's no hard fast about why we can't do it. Byung, if I have to answer the question. Okay. Yeah, thanks Shankar for adding them, from chiming in better. So Byung, did I answer your question?
Yes.
By the way, by the end of this deck, I'll also even answer the next steps of it. The deck which I have actually put part of next steps will also answer your question. Okay. Any other questions, guys, before I proceed on? Okay, so if I have to talk about, I spoke about the infra layer and how it looks as part of this complete distributed. If I have to go beyond it, the user is the one who actually gives a complete resource. He defines a subcloud custom resource, and then he deploys it on top of the, he deploys on top of Kubernetes using the OCloud operator. OCloud operator, as I said, is an extension to the custom resource controller, the CC part, which we have been talking about. And that will be then continuously running the reconciliation loop to see how these clouds are managing. So any change you want to do, you want to do addition of a new cloud, deletion of an existing cloud or subcloud, or you want to actually, update it, patch it, all those things can be then put as part of the resource. The resource will then map to a specific operation, and the operations is triggered by the specific operator which you are running on this. So this is how it works. And as I said here, the depiction, you clearly see it. We read from a YAML file, and then we execute the Ansible script for that. Right now we put Ansible, but this script can be anything, can be any code which can then be triggered on. And then that's how the complete the current state versus adjust state is the current state versus desired state is maintained, and then we get the complete desired state as part of the cloud infra. So this is the overall logic on which it works. Now, if I have to extend this same to the next topic of it, which is the IAC-based GitOps. IAC, as I mean, is the infrastructure as code. I can then extend this further. As I said, if the user has to modify and then put the resource here, the next step of it is why don't we keep the resource itself as part of Git, right? And then we can go with the GitOps base. So what we are trying to show here is if I put the same as part of Git repo, and then the user will be able to modify it, we can run a CD pipeline on top of it. We have multiple CD pipelines which are already there from CNCF side also, like Argo, Flux, and all. So those can be reused here. Even we can also use Jenkins for that matter. I mean, Jenkins-based workflows and all. So that can pull the changes. I mean, we can actually have a pull event based on the change when we have a Git. The user will put it on the Git. We will have a CD pipeline, continuous deployment, which will be monitoring it, and then it will actually sync the status to this. That will internally trigger the OCloud operator, and then we can resist it. So this is actually a scenario which we can further extend it to have the complete automation done through a GitOps mode of it. I mean, this is actually I can say version 2 of what we are trying to do. Right now, we have not yet implemented this part of it, but this is very much easier to do once we have this. So we have implemented this part of it right now as part of our demo. And we can also extend it further to this mode of it, where we can make it complete automation through a GitOps mode of it. The same can be even done for delete part. We are trying to show delete and edit and add here, and it's almost the same operation which we have. Okay. Demo. With that, I want to hand over to Seshi or Sunny. Sunny, Seshi, you want to you have the permission to share your screen, or you want me to run the video?
It's a short question before you hand it over to your friend. I mean, I have a question here for your GitOps for your GitOps pipeline. I mean, if somebody deleted, I mean, a resource from the class or deleted the class or deleted a resource from the cluster itself, does it go the KTS operator will reconcile to the desired state, or if, for instance, do you delete something manually? Does it your GitOps will reconcile to the desired state?
We have not implemented Camille. It's Camille, right? Who is asking the question?
Yeah, I'm Camille.
Yeah, Camille. Yeah. So as I said, we have not implemented it, but it can be done. For example, what Camille is asking is, Camille, you can correct me for this. In this scenario, if someone goes and modifies this, if someone manually deletes this, the reconciliation loop can run this. Yes, it's very much possible that way. That's what we are talking about, the desired state versus reconciliation loop, right? So it's very much possible to do it, because what we require here is 3 subclouds as per the resource you define. I mean, you define here the CRD we are talking about, custom definition. So if that is deleted, when the reconciliation loop occurs, it will know that this is not there, and it will actually try to add it back. That is how we can actually have the logic written here. It's possible, Kevin.
Okay. Session one comment. There's the Git
just one thing.
Yes.
The same is actually what we can also do for replica count. If I have to talk about replica count, Kamil, right? We have a replica count state, right? Where you can say this specific resource has to have so many replicas. Like I have to have 2 or 3. If one replica goes down, then the reconciliation will work on and can also bring back the replica also, right? That is possible. Hope I have answered your question, Kamil.
Yeah.
But the logic has to be brought in here. I mean, we have to have, if the trigger happens, what should happen to the logic, as I showed here, right, in the before. When a trigger happens, what should happen to the specific logic is what we have to implement as part of our business logic. With that, it should be able to work. Yeah. Hope I have answered your question. Yeah.
Session, one question. So Git is the source of truth. So if somebody change manually to cloud, so that means the Git has some other configuration, then you will push, and then they will change again. So that's why it's better to change the Git if you want to change it.
Yes.
Okay. Yeah.
Yes. So that's exactly what Kamal was asking. Kamal was asking if someone manually deletes it, will it get it back? That's exactly what we are saying. The source of truth in this is Git. Okay. With GitOps, the major advantage is the source of truth is Git. So you will know your desired state as part of your repository. Any change which has to be brought here. If it happens this way, that event is triggered from the layer, the infra layer, then that will be reconciled and put back in as per the Git source of truth. Right? Yeah, exactly. Any other questions, guys? I'm not sure if Seshi, Sunny, you have the permission to share your screen. You want
I'll
me to
just
share you want me to share the video and then you can do it?
Yeah, I think currently host is disabled screen sharing for me.
Okay, I'll do one thing. I'll run the video. Or Kenny, if you can hand over the recording, co-host event to Seshi, please.
Done.
Thank you. Seshi, you should be having the sharing.
Yeah. You guys can see my screen?
Yeah.
Yeah. Thank you, Shishu. This is a small demo of deploying OCloud from operator through CAS manager. Okay. So on this left top corner, what we see is the machine where we execute the commands. Okay. And the next tab, 128.224.248 and 54. This is where it's our target device where we want to deploy the cluster there, and 160 is our CAS manager. Okay, with this, let's go through the demo. We have deployed the OCloud operator here on system 146, and the Kubernetes manifest is what I'm showing. The name of the subcloud is the subcloud 1, and the target device is .54, and the CAS manager is .160. And let me go back a little bit. Okay, this is the target device, and as we can see here, none of the kubectl commands are installed. Now we will deploy the manifest here so that it can go ahead and deploy the OCloud through a CAS manager. As we can see, the bootstrap has been started. Rest all is just sit quiet. The logs will go on. I'll just move a little bit. It's still in progress. So once the bootstrapping completes, we can see the cluster deployed on. Yeah, you can see here, right? On .54, we can able to execute the kubectl commands now. Means the cluster has been deployed. The OCloud itself is up and running now. This is a small demo of OCloud operator.
Which cluster provisioner do you use?
Actually, we use the Starling X CAS manager, and the Starling X CAS manager will deploy the subcloud on the target device.
To answer the question, what we have done is we have taken the current implementation, de facto implementation coming from ORAN SC INF as part of the ORAN SC project, and that is built on top of Starling X. So the current CAS manager which we are using is Starling X CAS manager. Come in. Okay. Did I answer your question? Hello?
Yeah, thanks.
Actually, it's not me who asked the question, it's somebody else.
Oh, sorry. I heard your voice actually, sorry.
No,
yeah, sorry, whoever was gentleman, actually, yeah, I hope I've answered the question. Thank you. Right. So what we are showing here is the subcloud. You see, this subcloud is what we have shown as part of the previous presentation. I mean, as part of the design, as part of the deck which I was talking about. So what he was talking about is two things. One is, of course, the subcloud has a central cloud which actually takes care of the deployment and all. That's a CAS manager for us. And what we have shown here is using the operator. I mean, a single click, you can actually have all your thing deployed. And the trigger will then be able to add your subcloud. Similar is actually what we can even for design delete also. Sishi, perhaps you can leave it. Any questions before Sishi shares the screen?
One question. Sashi, looks like you are using Flux Helm here. If you go back to your screen.
Let me share.
Yeah.
The demo screen.
Yeah. We'll share it.
Yeah.
On that one, there's the Flux Helm. So using Flux Helm as a CD
So,
and then
the
using
Flux Helm is also deployed as part of the current thing. And it is not used for CD. It is not for CD. That is actually, I know what you're talking about. You're talking about the Flux Helm container which is running on that, right?
Yeah.
This is actually done as part of the deployment itself. As part of the deployment, de facto applications are being run. Flux CD also is one of them.
Okay, I got it. Okay.
It is not that specific thing which I'm talking from the GitOps perspective, but yes, we can extend it even using Flux. If I have answered.
Yeah. Thank you.
I see. Sure. Yeah. Just from curiosity, your cloud operator is Ansible based, right?
Yes, our operator logic is actually Ansible. I would not say our operator is Ansible, but yes, logic we have written right now in Ansible place, but we can even replace it with other other languages also coming.
Yeah, I mean, Ansible, it's Helm based is almost suitable for stateless. But if you have a stateful, I mean, it's rather to go with Golang based.
I'll put it this way: as long as I have the APIs being called from here, it should not be a problem. Because what we are trying to do with Ansible also is we are triggering the specific APIs itself, right? We are not using Ansible as a workflow engine. I mean, as a automation tool. We are mostly using it as a triggering tool in this specific case. So we can in fact, I'll answer your question in the next slide of me, where I was showing you how this operator can be used in other places also. But Kemal, to answer it in brief, I think I already have your answer, right? That it's an API specific thing which I'm triggering on. So I've not used Ansible as in the workflow. I've not used Ansible playbook or Ansible tower as in the complete workflow part. I've just used it as a triggering factor, right? So whenever I get a trigger to the operator will then call my business logic. Then the business logic is actually what is written in Ansible logic to trigger the specific APIs, right? Okay.
Yeah, I have a question. Seshu, I know this is the purpose of this demo is to just show the cloud deployment, but just curious, since it's done with some purpose in mind, can you comment on sort of what kind of servers and the list of pods that are there on the screen? What was the general intent about how many CUs and DUs?
Okay, this is the FOCOM part, Shankar. I know what your question is. Actually, this is more of the FOCOM part. I have not come to the NFO part to talk about So from FOCOM perspective, what we have is one central cloud with one edge cloud. Okay, that's what we have right now. So edge cloud has been on XR11. Okay, if I have to talk about from infra perspective, the XR11 is what is the subcloud for us, and even the central cloud also is XR11. Starlink, the advantage of Starlink is pretty lightweight. It takes 2 core. So I don't even require big servers for that. So I have taken two XR11s and I have actually deployed both the things in this. So one which you see on the left, I mean, the 14854 is the server which is pre-deployed. Only the infra part is actually there. It has nothing, as Sishi was showing in the initial part of it, right? The triggering of this actually happening from the 24854, as you see as part of this one. The main cloud, which is the system controller. System controller is then triggering the subcloud to be deployed. And then that is being deployed on 160, that 248.160. So 248.160 has been brought into the complete network, and then the complete manager, that is including the bare metal, from bare metal is what we have orchestrated everything. So if you actually, I mean, anyways, we'll upload this video to it. The video was a little lengthy, but if you go to the complete log, which we have running as part of 160, right, you will see we have done from the go of bringing up the BIOS, then the firmware, then actually the other things also. So entire thing has been brought up from it's a bare metal orchestration.
Nice.
Right.
Okay.
By the way, this logic is already implemented as part of Starlink. Yeah. Sorry, go ahead.
Yes,
Shankar,
two servers, one for central and one for edge. Right?
Yes.
That's what you're showing.
Yeah. So the edge part has been brought up completely from scratch. Central is actually what is the management lane, which is the control plane, I would say. From the perspective of the OCloud, yes, that's the one which is getting triggered by the operator. And then we also give the target as part of CRD. I have the CRD also as part of my presentation. If you have noticed it, I also mentioned about. Okay, Shishi, if you can share, if you can stop your share once, please. So here I was mentioning it, right? I mean, I gave the details of. Sorry.
Mm-hmm.
As part of my definition, I have actually said which group it has to be, which kind it has to be, which version it has to be, all this. So this is what is my CRD, and that is actually what is triggered here. Anyways, I'll be showing it as part of demo slide also. Give me a second. Yeah.
Okay.
So this is a complete deck which I was showing you about the video which is run, right? This is the complete CRD. The custom resource definition is here, and then this is a complete CR which is actually having the values for it. As you see here, the system control address is 160. Okay. And then we have the subcloud details which are passed here as to what should be my trigger. I mean, first of all, I should tell the operator as to what is my trigger factor, what has to be triggered. This is actually answering even the question of Kamil, right? About what is Ansible doing. Ansible is actually triggering the resource which is mentioned here. I give the target IP as 160. And then I also say which operations have to be done as part of that. So once I have give this to the CR is then executed. And then finally, I'll have the complete thing. So here Ansible is actually running here. We have a playbook path playbook where we are doing the specific watch for this. Okay.
Mm-hmm.
Yeah, thanks.
Yeah. Any other questions before I go to next steps, guys? Any other questions on this? Okay, so this is what we have done as part of the complete thing. I think I've already answered it, Pravet, but before, just before going to the next step, I want to just tell what we are trying to illustrate here. So we are trying to illustrate how operator has to be initialized, then what we are trying to automate with that Ansible, define the watch file. I mean, the watch file is what will actually be the desired state. I mean, that's the source of truth. That watch file is something which we can also put in Git. For example, if you have to have a complete GitHub, that will become the act, right? Infrastructure as code. And then we build a cloud operator, and then we deploy the cloud operator. So what we have used here is Operator SDK built OCloud operator version 001. And deployed OCloud operator on Kubernetes cluster. So that's what we have done as part of the entire operation. This is the CRD. This is a custom resource, which is actually done as part of that. And finally, we have the Ansible, which is triggering the specific API of the Sterling X deploy, right? So having said this, now next steps. Okay, I think this is what I was talking about, answering that Hatha's question. So as you see here, I'm part of all these projects from the LFN perspective. I can also put Tracker and all, but I put Tracker as one more scope of it, just because Shankar, you know it, of course, other people who have been working on the ORAN spec, you know, there are two kind of profiles which we have. One is coming from the Kubernetes profile, the other is actually coming from HC profile. HC profile is currently run by Tracker, and then the Kubernetes profile is actually what we implement in the ORAN SC using the Kubernetes way. So as part of the SMO project of ORAN SC software community, we want to show how we can actually have all these pieces together. If you have seen what I was showing as part of the Nefio, right? Nefio is the one which will take care of these two layers. But if you have to talk about the end-to-end orchestration of it, that includes the layers apart from CNF also, the service and how the service should be composed with CNFs. And also if I have to tie the CNF with other PNFs and BNFs, then comes a layer like ONAP. ONAP is the best suited thing for that end-to-end orchestration. So what I've taken is this SO here. So what we would require to do as part of this, I mean, okay, let me depict what this lines mean, the line color code means. All the green is actually done, is something which we have done as part of this project, or so far what we have done. And then what are the black ones are the dotted lines is something which we might be doing in future. And this dotted line is something which we will be doing in the very near future. So the blue line here is something which is very futuristic, which we are talking about from the perspective of intent driven and all. So what I'm showing here is only the FOCOM part. If I have to talk about the NFO part also, I think there was a question from Byung about NFO, then I have to talk about this SDNR and further down to it. Even there, the same can actually happen. As I said, IMS is what we are doing, but DMS also is something which comes into picture. And that answers your question, Byung, about the NFO part, right? That is what DMS.
Yeah.
So what we have done right now is IMS part, but DMS also can be done in the similar way. all it will require is we have to have that specific workload to be triggered, and the workload trigger can be then calling the specific APIs, and that should be giving you the multi-cloud infrastructure, whatever you're talking about, right? In Nefio also, once the Nefio release 1 is out, we will also try to have this particular thing. I have a slot in the upcoming Nefio meeting, 25th May, where I'll try to present the same thing. By the way, this same thing has also been presented in the ORAN SC community, both in NARSAC as well as talk, and we got a very good feedback even there. I'll also intend to present this in the ONAP TSC very soon, okay, where we will also talk about how we can have all these community collaborations. The Anuket part, Heather, to answer your question, the Anuket part is something which will come as part of this testing and validation. Once I have all these pieces, I can actually bring the Anuket piece also to have the validation and the testing progress of it. Actually, if you have to talk about the OCP part of that, that is where we were doing the CNF validations and all, right? That is what will come into picture for that specific thing. Heather, I hope I've answered that question also.
Yeah, I mean, I think it would sort of also go kind of near where you've got basically Silva kind of on the diagram, because Silva certainly has some dependencies there. And I think that relationship is still, you know, kind of being worked out, especially because Silva's a bit new. But yeah, I mean, if you were wanting to put the logo on the diagram, that's where I would put it. But I think the other question, you know, kind of still stands in terms of both Silva and Anuket, you know, being able to have a little bit more of an understanding of, you know, kind of the ORAN infrastructure, you know, sort of requirements, so that we're able, you know, in concert as a set of projects, you know, work towards the ecosystem goals together. So that might be a line of communication that needs to be set up.
Sure. I'm happy to say one thing, Heather. I'm happy to say one thing, that in Silva, I have been nominated as the license officer between Silva and ORAN SC.
Okay.
I think that answers most of the questions which you're talking about.
Yeah,
right?
Yep, exactly.
So I'll be go-to guy. And the reason why I put Silva also is because, see, Silva again is a conceptual thing coming from different amalgamation from different open source projects. Yep. In that, if you have to talk about the ORAN specific thing, which we are talking about as part of this project, then Silva also will be can be built on top of OCloud, right? The OCloud of this ORAN SC can be the part of Silva also. Hence, I put Silva here as a little above OCloud, because Silva scope will be little, I mean, something else apart from the CNF alone, right? So that is what we are talking about here. Yep. The MCO piece has actually come into here because we know that MCO can do edge multi-cluster orchestration. It's a CNF orchestration, to put it in that way. It's a Helm-based orchestration. So if you have to go Helm-based way of doing it, then we can use the SO as end-to-end service stitching. Then we can actually have the CNF adapter to talk to MCO using the Helm way, and then we can go. If I have to go with the KPT way, then Nefio comes pretty good for us, because KPM and KPT is what Nefio uses right now. I mean, as of the release 1, and that from there we can actually use the same piece. So what I'm trying to say is this piece of box can be implemented, can be integrated to any of these processes. I mean, any of this MCO, SO, Nefio, and then that can actually bring up the complete functionality. So what I try to do as part of this project here, the why I'm saying is cross-community collaboration, is because the same piece of the code, I mean, the same IMS piece of the code, which is developed right now as a POC, can be reused in all these places. We don't require to reinvent the wheel. We don't require to rewrite the code. So it is written once and then reused in multiple scenarios, right? So that is the advantage of having operator-based implementation, right? Because the other thing is completely abstracted from the user, and what we have is the orchestration piece. All that you have to do is just to stitch it to the specific piece of it and go ahead. Now, I also want to add, the question came from Yogen, actually, my very good friend from ORAN community. What he was actually asking about is, should we bring this project completely up from scratch every time? No, that's exactly what I was showing here, right? From SO perspective. SO actually has CNF adapter already, Yogen, right? And that can also be part of this. So if you want to go the MCO way using Helm, we can very well use this APIs which are there, and MCO can actually take care of the OCloud implementation also. Right now it's dotted line, but when we implement that as part of MCO, we can actually do this also, right? And the same is going to be scaled with Nefio also, but if we can, of course, Nefio is operator based, so why don't we implement the same thing? I mean, we can reuse the same piece of the code in Nefio also, and then that will solve the problem of ORAN integration. Okay, hope I've answered all the questions. Byung, Kamel, Heather, Yogen.
Yeah, yes, great. One question, actually 2 questions. You put the ONAP title, but could be OSC for some, this architecture stand. And also, the second question is you talking about.
I didn't get your first question. I put ONAP, but what was the question?
No, even though you put OSC, you will work. That's something. SMO. If you put SMO, you will work.
Yeah. SMO part of it, I'll come to the SMO part. I'm right now showing all the orchestration bases. I've not talked with respect to SMO. SMO part of it, I'll come to the next slide of it.
Yeah. Okay. So one comment then. The one pass for Helm, you choose MCO, but Nephew currently
I know.
Yeah,
I know.
And then
as I said,
we are.
I put Helm here because this is already done. But as I said, I mean, when I was saying KPT, I said Nephew also has this in roadmap. Okay, but not in release one. I'm talking about. I clearly mentioned this MCO Nephew here. I said as part of Nephew release one, we don't have Helm, but in Nephew we can also do this Helm. So I said that's the reason why I'm putting this green right now, right? Green because it's done, and CNF adapter is very much doing with MCO, so we have put this thing. But it can also do Helm in the coming releases. I was talking about release one of Nephew more precisely.
Thank you. Great.
Yeah. I'm very much aware because you and me are partners in crime for all these projects also.
Yeah, I know. Okay, thank you. It's great presentation. Yeah.
Yeah, sure. I mean, I've been a little, I would say, this is my dream to have this intent engine here. The intent engine which I'm talking about can actually become part of anything here where I don't even require to do this. I mean, to add to this, my dream would be or my intention would be to have this intent engine as part of the complete thing. The intent engine, I put it out because right now we are trying to do it as part of SO. You will see this presentation of it even tomorrow also, where we are talking about intent engine, how it should be part of ONAP. But that can even be something which can go to MCO. MCO also has placement and placement intent right now. Well, that is a starting step of it, but we can also extend it further. We can also do the same in Nephew as part of the future releases. So the intention to have this intent engine is as a futuristic thing where we can say that the entire triggering and other things can also become as part of intent. The user can just give his intent and then everything should go, right? Maybe NLP can also be part of it. I mean, I'm daydreaming right now, but the future is something which is in our hand, right? So we can also put NLP here, native language programming. We can also put intent. We can also say that I just want to add this subplot and everything else should be happening. ZTP, the zero touch provisioning. All these things are something which we can do as part of mutual collaboration. I'm sure we as part of the LFN group can achieve great heights, and this is one part of it. Right? So to answer the SMO part of it, Byung, I think I could read your mind. We are having some telepathy going on because you are asking a question. I have the slide for that. So the SMO part of it is going to be coming here, where I'll say SMO end-to-end integration is here, endpoint. And this is the integration part which I was talking about. One is Helm repo part, other is Docker history. And overall, I mean, this slide deck is something which I have integrated with multiple designs or iterations of it. This was one of the things which you have showcased how the O2 IMS part and O2 DMS part will integrate with SMO with different operations as you see here. So these all things are something which we can do as part of these operations. Right now, we have only taken this part of it, the OCloud inventory and get O2 IMS, and then we have done the deploy part of it. But in future, we can also do this for other operations where the DMS part also will be involved. Okay. I hope I've answered that question also about SMO integration. Okay.
Yes. Thank you.
So the operator is coming here, as you see, right? The operators are
here. Yes. Thank you.
So the next.
I was going to say, Seshu, one thing that's obviously clear, given how many questions you're getting, is that this is obviously a topic of extreme interest. You've woken everyone up and gotten us all engaged.
Yeah,
so I put very well done on that front. I mean, I think that this really is important, and it's complicated because it does involve lots of communities sort of working together. But I think all the questions is a testament to how important this is, how exciting it is, and the fact that lots of people are interested.
Yeah, thanks for that recognition. Yes, and I can tell you one more thing. In fact, I've been presenting this to different groups. I was going group by group. And every time I present to a group, I have a lot of companies coming to, with a great interest to have their hands in this. And yeah, it can become almost, it is as good as Super Blueprint, right? 5G Super Blueprint. It can become one more project like that also, if we take it the right way. So it has all those traction points. By the way, we don't require all these pieces also to work in collision. We can take some of these pieces also. By this, what we are trying to show is different ways in which this integration can happen. And this integration can take in multiple shapes and forms, right? Yeah. The other part to it is, of course, the future developments. The first and foremost, I think this is a question which Byung asked. Byung, I'm keeping this top one. I didn't modify the slide, by the way. It's already there.
Sure. Okay. Okay.
So OCloud DMS is the one which we'll actually target as part of next step. Of course, the IMS itself has to be extended. What we showed is, I can say, we are just scratching the tip of the iceberg. We didn't even get into the details of it. We have just scratched the tip of the iceberg. What we have here is, of course, the LCM operations. As I said, LCM operations, when I'm talking about, we have to extend this to other operations of the O2 IMS itself. Then GitOps based, I've been talking about this, the reconciliation loop and all with respect to GitOps. So that also is something which we want to do as part of this. Intent-driven orchestration, that's a long-term goal. Control loop driven, where we are talking about control loop, the trigger which we are talking about is right now in the reconciliation within the OCloud operator itself, but I can also extend it further to the Git, right? I mean, why don't we even take it to the next step of it, where I can say that the event which is triggered from the from external resource can actually also change the Git as a user input. So that also is something which we can do as part of the entire control loop. Also, we can also do this activity about the FCAPS part of the integration, right? Where we monitor all those events which are happening on the system, and then we can do a reconciliation also. So those are things we can talk about the control loop. This is what we have been doing, bring it to larger audience and participation. I need all your support for this. If you see this has some value, then we can actually raise our shoulders, raise up our sleeves and make our hands dirty to make it work. Integration to broader communities and demos in ORAN, Nephew, ONAP. So that's what we have been doing actually. So far, I did in ORAN. Of course, this is a better forum for us to do integration. In fact, Heta, to answer your question, I had a big question about where should I put this topic, because I was not sure which category of those topics, right? Whether it should be general topic, it should be part of ONAP, it should be part of MCO, it should be part of Nephew. I had to break my head to see where it can come. Then I thought, okay, forget everything. I'll put in general topic, because I'm sure
Exactly.
you'll be at least for one reason, that if I put general topic, I'll have Heather on the online and she'll take care of it, rest of it, right? I was sure of it.
Yeah, and one thing I also want to say is the topic coming up after the break. You sort of referenced 5G Super Blueprint, and the topic coming up after the break is sort of the role of Nephew and ORAN and infrastructure in 5G Super Blueprint. So I think that this is going to follow on very well with what you've been presenting here. So I hope that we can sort of remember this topic and bring it into the next discussion in terms of how we facilitate these integration points and these larger scale initiatives within LFN and inside and extending beyond LFN, because I think that's one of our, I think, crucial things that the ecosystem is asking for us these days.
Yes. Because we have all these pieces running in silos right now. The biggest problem I have is there's a lot of duplication of work which is happening here. My intention to do this job was to make sure that we do it once and we can replicate it multiple times. I mean, why should we reinvent the wheel, right? And already we have seen that the contributions are not easy. They have to go a lot of pressure. We have to have a lot of effort being put in all these contributions. So when I see this, I also get, when I go to, I'm open source enthusiast, evangelist everywhere. So I get a lot of these questions about these different orchestration pieces. So as part of this, what I wanted to even show was what each of these orchestration piece, coming as an orchestration expert, where do they fit into and how do they can interconnect? That also is something which I wanted to talk about. And I hope this slide is talking about it. I also put Tacker because that is not in the elephant scope, but it's still something which can do orchestration, right? As coming from open source, from the OF. And even that can also work with this. We are also actually getting onboarding of Tacker as part of the SMO integration for the Etsy profile. And that also is something we want to have as part of the mission, right? The end-to-end pieces of this orchestration piece, how they can work with IMS as O2 IMS as an example. That's the entire intention of this entire workflow. Okay. I'm glad it made impact. And thank you. Any other questions, guys? I'll be more than happy to take it. Thanks for the comment, Bian.